Okay, I'm back with another update, and what I've done here is I managed to get the 512 batch size working. The reason why it wasn't working was just a memory constraint. So I've here now a machine with approximately 512 GB of main memory. And what I did to verify if this all works, I just ran this job and I put here batch size of 512 in, and then this job actually ran. So that way I made sure that the job itself is running on the machine without creating a huge cat experiment in advance. Then another thing, I had a theory that due to randomness, I might end up with different validation accuracies, but it turns out it's most likely not true. But obviously I will show you later how I want to validate this. And I also identified another source of randomness. It's not only the initial values of the weights of the neural network, but also the data sets are returning the images in a random fashion, and that's also steering the trajectory of the gradient descent, obviously. But anyway, we can already see two interesting things. So first of all, about randomness, we can see that we have here a run variable. And let me show you how I created this run variable. So run means I'm running the same experiment multiple times. And it's very easy to do this. What you need to do is you go to this job submission, and here what you do is you say just introduce a dummy variable, which I call here run. So this will be ignored by the training. And then what I do is I define in the hyperparameters, I define a discrete variable run. And I say just 1, 2, 3. Okay, that's what I did. And that way the same experiment will run multiple times. And that way I can at least get a glimpse whether we have a huge variation in validation accuracy due to randomness, which at the moment doesn't seem so. So please note that this line here is actually currently training. That's why here we have 0 values. But if let's go for another example where we have 2 runs. So this is with a batch size of 512. And you see here in run 1 and run 2, we have similar trajectories. Now we end up always here at a very low value for validation accuracy, and also we always end up with a very high overfitting. And this region here is actually a good value for batch size. I mean, I have to fix this model anyway to get a higher validation accuracy. That's another job. That's actually why I was creating this whole thing, with catip and so on. But since this batch size thingy popped up in Stack Overflow, I just wanted to use this as a first experiment. Okay, yeah. Okay, let's go to the trials, and let's have a look which batch sizes are actually good. So you see here 2 is good, 4 not, 16 is okayish, and also 1 is okay. So it's interesting that 4 is not good, and it will be more interesting if we see the second and the third run of a batch size of 4, if we see some surprises here. In case we do, I obviously send you an update. But to me, it seems that 1, 2, and 8 and 16 are good values. Also 32. Then with 64, it starts to decrease rapidly. And obviously, I will go another round over my code to double check if, let's say, 64 and above has some other implications. At the moment, I guess not. But yeah, that's basically the proof that batch size is a hyperparameter you should also tune, and you should keep it in the usual range between 4 and 32. Okay, that's all for now, and I'll give you another update if necessary. Otherwise, I continue this whole experiment with more relevant hyperparameters, and obviously then at a later stage go into neural network architecture search. And another thing I will also create a video soon on is Dapr. Dapr is a pretty cool library I found, which actually allows us to create sidecars to pods and turn components or containers into either web services or REST services or messaging services. And that's very handy for my claimed library, because you remember I have these notebooks which actually are a way to express those Kubeflow pipeline components or Airflow components or container images. And I've hand-coded some of those to accept REST calls, and also I was planning to also support message queues. And with Dapr, this is like done for me, because Dapr actually then calls the REST endpoint on the components, so I don't need to support message queues, and also it abstracts on different message queue systems. So that's pretty cool. But I'll send you an update on that soon. So all the best. Thanks for watching, and bye.